Well, my mom got mad at me this weekend. She was the last time Woody. She got really mad.
You're just sleeping, so
She was like, when's the last time you ordered retainers? And I was like February. So she told me I had to put them in, and they didn't fit. So I had to like push it super hard. And then I woke up at 1 o'clock because it hurt so bad. And then like shoved them in the rest of the way. And now my teeth are straight.
Yes, you did. What did I want?
Impressive,
you
right?
scanned.
Yeah.
Very impressive.
Did you give motion this hat to you? Look.
We don't?
Answer.
You're an answer worker. Yes, I gave him a hat.
Mrs. Research is really
That we were going that last night, and then I took it off, and I don't know where I put it. And I was in her house, so I couldn't find it.
What?
Miss Research.
No. Today? You were. That's Jared. Jared was in the car next to me.
Jared who?
What the? Don't get it. That was weird. Is that weird?
One of them just stays side.
No, it's not.
I'm
gonna
looking
get
at
mine.
the okay, anyway, okay, hold on, go back to the story. And then she was like, you usually have to come for true conception. I'll admit it, I'll admit it. It's gonna be really hot. That was right hot, it was like 9:30. And she was like, well, I don't know, but it wasn't even that cold. There's something wrong. And she was like, I don't think we'll get out. I was like,
You know how there's 3 exercises? At the first done, second one was like half done,
yeah, I talked
third
about
one we
this
didn't
morning.
finish.
It said he's not
Oh,
sure.
so when she asked me for
Talk
the
to him
third
about
one,
it now.
luckily someone wrote the answers and showed it to Phil.
Wait, was this supposed to be good?
It's hot.
Yeah, class.
So I was like,
For what? Wait,
Well, it does like the 3 exercises.
Or
and
if-
turn it in. No, we didn't turn it in. I don't know why we even go through them because we just threw them away. It's not creative.
Wait, what?
Yeah, but you get homework today.
Yeah, we get homework.
Yeah, we're supposed to throw
Wait,
this
So
away.
these guys are finished.
No. Yeah, here.
I mean, they have to be finished, but they're not made.
Sure, throw this away.
Just don't worry about it.
All right, welcome back. Just a reminder. Tomorrow, page 43 is due. I will give you time today to work on it. We're just going to do a brief introduction. What we're going into tomorrow for sure. It's pretty straightforward. The stuff we're going into is not hard. It's just something I just want to remind you of how to do because it's still the prerequisite stuff. Remember, today and tomorrow is kind of the last days of the first half of the prerequisite chapter, and then we take a pop quiz. We'll probably take a pop quiz next Monday on that. That's one you can retake if you wish. We'll look at the practice guide maybe Thursday, Friday this week. We'll do a review, okay? But that assignment's due tomorrow, so I want to give you time. I had some people in here this morning working on it. That's great. Remember, after school today, I'm here till about 5. So you can always come in after school, and then I'll be here tomorrow morning if you have questions on it. And plus today, once I give you time in class, you can ask questions if you have any. All right, but today, let's do a quick introduction of what we're going into, just to make sure. We're in P.4, just so you know. P.4. The title of it is called Polynomials. Just kind of talk about the polynomial itself. Most people know what they are, but unless you've seen like a formal book definition for pre-calc, you've never seen the level of what we talk about for it. So the first thing we're going to do is we're going to go with the definition of a polynomial, just to show you like the actual written form of it. Then what we're going to do today is just talk about some basic operation stuff. How to add, subtract, multiply. Basic operations. Notice the only thing I left off, division. We won't look at division until later in this book. I don't know if did you guys ever talk about how to divide polynomials?
No.
And okay, all right. So that's something that we do spend some time on later. I know like tomorrow we'll get a real brief introduction to division. It's not the long division stuff that I want to go over, but we'll talk about some basic simplification stuff. So this is kind of our goal today. That's what I want to get through. It's very easy, just introduction. Then I'm going to give you some time where you can actually work on your homework. When is our homework due? Tomorrow. So it's due Wednesday. So just make sure that I will hand back some old homeworks today. So as you guys are working, you will get some papers back. So I think that page is what 43. So.
Even if we miss like 2, can we redo those?
Oh yeah. That's what I allow you to do. Just make fixes, put it on a separate sheet of paper, staple it to it. So it could be just something stupidly simple, like you wrote down the wrong number, like just you wrote down the wrong power. I saw somebody do that once. So, or I circled some things like you put the wrong power on the bottom of a fraction, that type of thing. Question
So we have to use the ones.
that you missed.
Those
Yeah.
ones, right?
Yep. Just you gotta staple it to the original though. That way I can actually tell yes you did miss number 10 and there's making that up. So. But yeah, so, and always pay attention. When I hand back homework, hold on to it for a couple days, just in case, because I know, like, I tend to, like, I grade papers, I hand them back to you, and then I notice, like, one day later, I forgot to put your score in. Like, I just forgot it. Like, it was out of the 40 people that were in your, or 20 people that are in your class, I forgot your paper. So just hold on to it for a couple days until you see that those scores are in the grade book, and you're good, and then you can throw it away, or recycle it, whatever you want to do, okay? Just hold on to it, because they are graded. I grade every single problem. It's just, some days I'm going so fast, I just missed your score. I just I was maybe stuck to another paper, or I just flipped and I didn't think about it, that type of thing. So it does happen. I'm not perfect. So, okay, let's talk about the definition of a polynomial, and then we can talk about the classifications with that. All right, polynomial. It's got almost the same definition of like an algebraic expression, because that's actually a part of the definition. It's an algebraic expression where numbers and variables are combined using basic operations. Now they have this weird notation for how they write this, okay? And so this is the brief, like, paraphrasing from the book. I'm not giving you the exact word for word definition what the book says. Okay, this is like the brief, like pulling out the main points. It's an algebraic expression. That's what a polynomial is. We have numbers, letters, combining basic operations. Okay, but here's the specific thing that I want people to see for the first time, because you've probably not seen this in other classes. This notation. This notation. Yikes. That is a polynomial in what they call descending order. That's how that's standard form for a polynomial. So this is standard form.
Should we write that?
Yeah, I'd like you to have this somewhere in your notes. Standard form for a polynomial, descending order. Now I will explain this, because when you look at this, it's crazy. There's a lot of letters, n-1s, n+2s, that type of thing. It's just weird to look at. It's really weird to look at it, in fact. And I just want to make sure that we understand how this works. Oh, I forgot an a to the 1. That makes things goofy. A to the 1, x to the 1. There we go.
What's that last one? A to the what?
A to the 0.
Oh.
Yeah. A to the 0 is that last term. Alright, I will explain this. I'm not just going to leave you hanging like, oh yeah, this is it, and then you're supposed to just kind of figure it out as you go. So, now this isn't telling you like a lot until you understand what each of these terms are. And it comes back to the definition we talked about yesterday with exponential form. That's just something you need to realize. So I'll let everyone write that down. There is a dot in the middle there, because I don't know how long your polynomial is. Okay, now what this stands for. If we just look at this first term here, a to the n, x to the n. What this is your highest degree item that you have. Highest degree. So, somebody give me a power of x. 7. I'm going to go 7, because that's just kind of a random number. It's x to the 7, right? And we can put any number out front. Let's say I put a 5 out front. Okay? if this is your polynomial and you have some other stuff written behind it, whatever this is, this would be your first term. If this is the highest item that you have and you have them all written in order and you have ones that you skip, the biggest item was x to the n, it's x to the 7th for you. Okay, the n is your power, it's your biggest power on that item. This term, the a to the n, is the number out front. Okay, it's this leading coefficient right here, it's the 5. Now, why do they have it like a to the n, or a to the n minus 1, or a to the n minus 2? We describe the leading coefficients by whatever the degree is. What I mean by that is sometimes I'll say, what's your leading coefficient on the 7th term? Like, what is your a to the 7th leading coefficient? Well, a to the 7th is the same as your x to the 7th. So, when you're looking at your big polynomial, the x to the 7th here, this is your a to the 7th leading coefficient. It's the first one. Why didn't I say the highest degree coefficient? Well, I could have said it, but the problem is that might not be the biggest number, and that leads people wrong. When I say like the highest degree leading coefficient, they might be looking for the biggest number in that polynomial. This is just the first one. Okay, it's a to the n. It's the nth term down the road, if I don't know how many terms there are. Okay, is there any questions with what this stands for? Now, if I went down and I went to the next one, this would be x to the 6th now, and I can put any number out front that I want. I'll put a 13 out there, it doesn't really matter. So this is now x to the n minus 1. It's the power that's one less than the biggest one. So it's x to the 6th. The a to the n minus 1 term, so that'd be a to the 6th term, is the 13. That's your leading coefficient.
So you're saying there'll always be an x term that's one less than a polynomial?
Yeah.
Always?
Even if they're, like, let's say you're missing it. Let's say we went down, we know the next term we had x to the 4th, and we had, we had a 2x to the 3rd, and negative 10x plus 7, right? Well, the weird thing is, like, what was supposed to be here? What am I missing?
5.
X to the 5th, right? It's still there. What is it? It's just a 0 x to the 5th. It's still there. There's every term is still there. They just have a 0 out front. That's why it disappeared. Because when you take anything times 0, it just goes away. But each polynomial has every term right in there. All right. Is there any questions with how a polynomial looks? Most people look at that and they're like, God, what is that? That first definition according to your book, because they have it in your book, and it's just when you look at it, God. But it's not hard to look at. You just know it's the biggest power with a leading coefficient. Next biggest power, leading coefficient. Next, and just get smaller and smaller until you get to the last term, where they call this a to the 0 term. Because it makes sense, because a to the 0, the a to the 0 term is the last term. It's literally x to the 0. The power on your x is the same as the leading coefficient degree, right? So x to the 0, this means the number 1, so it literally just goes away. So it's whatever this number is. It's just, this term is called a constant. That's what it is. Called a constant. It's just a number out back. So the constant in that problem was what, the 7 at the very, very end. Didn't have any variables on it. Okay, any questions with what a polynomial is? Okay, polynomials can be any size. Doesn't matter if it's a single term up to 7 terms or bigger. We just call them polynomials. Now I know that in Algebra 2, we have names for specific size terms, right? If it's a single item like this, where I just put a 4, this item is called a constant, right? It's just a number, a digit. I don't care if it's 4 squared, it's still a number, it's a constant. Okay, if they put a letter on it, like that, now you have what we call a monomial. Monomial, meaning mono, meaning 1. It's a 1-term polynomial. And then we could have a binomial, meaning 2 terms. And they can't simplify. That's what a binomial means. If you can simplify, then it won't be a binomial. Trinomial is 3. Most people are very comfortable with a 3-term polynomial. If you could simplify any of these, then it wouldn't be a trinomial anymore. Binomial. And then anything bigger than a trinomial, they just call it a poly. Actually, all of them are called polynomials, but anything bigger we don't have a specific name for it anymore. Any questions with like the different classifications of polynomials? Most people know them for algebra 2. It's not a big deal. Just I want you to know these terms because sometimes I use it. Say like, hey, add the monomials together. Find the like terms. That's what they are. Okay, so idea today. I want to talk about basic operations. How do we add, subtract, multiply these things out? That's what I want to talk about today and show you my little shortcut. Because I've actually hinted at how to multiply already. I think we talked about it on Friday. It's just I want to make sure everyone's on the same page how we do this. Okay? We good so far? Okay, let's talk about those basic operations and then we'll be done. I'll let you have some work time. Okay, basic operations. Let's talk about how to add, how you add terms together now. So this is addition. The big thing, just a reminder of just some vocab terms. When they ask you to add, polynomials together, add monomials, binomials, whatever they're doing, you're adding like terms. That's a big deal when you're doing addition. Let me put that in there, like terms. It means they have to have the same number, same variables on them, that type of thing, for powers anyway. That's what I mean by numbers. And the key word there is you're finding the sum, like the sum of. I'm going to put that in air quotes. Some people they always get confused. Like, what does the word sum of mean? Seriously, it's like a freshman math term. It means to add. Okay, so no matter what your polynomial is, 7x plus 3y plus 4, and you're going to add this thing to another one. 10 minus 5y plus 19 x. Okay, you can add these together. They don't even have to match. I just made them that way. So when you add, do I really need the parentheses there? No. The adding doesn't make any difference. So the parentheses can go away, and then you can just rearrange. So I'd move like the x's together. I'd move the y's together. And I'd move the numbers together, the constants. That's how I'd add. And then I just combine the like terms. Do we feel comfortable with that? Now obviously the final answer on this one, what is that? 26 x's. Negative 2y's and a 14. I don't care the order. Sometimes they always say descending order. It doesn't really matter. I don't really care. We good with that? Okay, now, the reason why I bring this up, what if it's subtraction? Now what?
There's -1 in front. You have to
Yeah, exactly. You have to distribute it. Anytime they put a negative here and you have a parenthesis, you need to distribute the negative sign before you start. Before you start. Don't start rearranging. You need to distribute this to everything in the back. It's just like our counter set. There's literally a -1 sitting there. So you have to multiply that through. It's called distribution. So now your problem is this. -10, positive 5y, negative 19x. You do different answers now than the plus. Because now you have the 7 minus the 19, so now I have negative 12x's. 3y, positive 5y, that makes 8y's. And 4 minus 10, that's a negative 6. Do you see that the answer is radically different than adding? For some reason, people always just think the negative goes to the 10 and then they stop. You have to distribute the whole way. This is like, if this is your problem in your book, I'd expect to see this as your first line of work on your homework paper. Like, that's it. You have to distribute. Then you can do everything else in your head. Question. Did I do some math wrong?
Is that 8x
Is
plus
that
b and 8y?
Yeah, y, sorry. Yeah. Rookie mistake. Yeah, thanks. I thought I did some addition wrong. Alright. Any questions with that? Okay. Most people are very comfortable with adding. Subtraction always gets the that one rule you have to distribute. Okay, now multiplying. There's two types of multiplying. two types. There's scalar multiplication, which I'll show you here in a minute, and then there's the thing where you FOIL, or distribute, however you want to think of it. Okay, so that's what I want to just make sure that we understand that. But again, with subtraction, that's this problem. Subtraction, you need to make sure that on this you are distributing first. Distribute first. And then you can go to like terms. Okay, now the key word there that from your book, what they like you to make sure of, that you understand that when they're doing subtraction, they're just gonna find the difference of, quote unquote. So vocab terms in case you read in your book, you understand what you're looking for. Okay, now let's talk about multiplying. Okay. Okay, I'm going to give you two types. I'm just going to be very brief. These are my last two types of problems today, and then you have the rest of them to work. This is scalar multiplication. You're going to take a parenthesis times a number. This could be in the middle of your problem, right? But on this problem, you have to multiply. So again, it is called scalar multiplication, because you're just multiplying by a number. So it's just distribute the 4 through, and you're good. Now, that 4 can be anything, right? It can be any number, it can be positive or negative, doesn't really matter. If you put a 4x out front, technically that would not be called scalar multiplication anymore, it would just be multiplying. And you would still distribute the 4x or whatever that is through the parenthesis. And you can still do that. Okay, and I just want to make sure that you're getting the right numbers. Now remember, when you do that, you're not affecting the powers unless there's an x out front, like a 4x. But right now this 4 just gets multiplied and everything, so it's a 20x squared, a, what was that, a 36x, and an 8. Now, can I do anything further after that?
Yes.
What?
Never mind, just kidding.
No. Okay, so don't try to add the x's together. One has an x squared, the other one doesn't, so don't try to go any further. Okay, now, moving on. If we had FOIL, first, outer, inner, last. Okay, they call it FOIL because you have a binomial times a binomial. That's what FOIL is. I don't like the term FOIL. I understand what it comes from, first, and then outer, and then the middle, and last. I just don't use it. I don't think of it that way. I think of that you're distributing twice. That's how I think of this problem. Even if it's bigger, you can still distribute. Okay, so the reason why I like to think of it as distribution, it works even if this problem's bigger, you can still do the distribution technique, where you just take this 4x times everything in the back, one at a time, and when you're done, then you take the 9y times everything in the back, one at a time. That works even if there's 3 items back here. Let's say this is a trinomial. You can still do the same process I'm showing you here. The 4 times everything in the back, the 9 times everything in the back. Now, how many items should I have written across? How many items are in here? There's 2, right? It's a binomial. How many items are in here? 2. What's 2 times 2? There should be 4 items written across. I know it could simplify later, but there should be 4 items across as you do this. That's how I think of this math. That's how I know if I did the right work. So 4x times a 5x. 20x squared. 4x times a negative 3. Negative 12x. Okay, that's just the 4 times everything. Now we'll take the 9 times everything. Now color code. 9y, bless you, 9y times a 5x is a 45xy. And then 9y times a negative 3 is a negative 27y. In fact, I don't even think I can do anything with that. No, I'm done. That's 4 items across. You can't simplify. The only time you'd be able to simplify is if the parentheses have the exact same terms. Like they both have x's, they both have just plain numbers. Then I know I can simplify later. If they have a mixed bag of different things, you can't simplify. Like different terms. X's, y's, that type of thing. Okay, do I need to do anything bigger? Do I need to do one where I put like a trinomial in the back or a trinomial in the front? Okay, tomorrow we'll continue with this idea of multiplying, where I do bigger. bigger items. Okay, and we might intro division tomorrow just for the first part because it was basic operations. Okay, the rest of the time is yours. You can work on this page 43. I want to give you at least half the class, which I did. Okay, video will be online tonight after school. I'll post this video so you can watch. Make sure that you write down the right problem numbers. That was a common mistake on the last homework that we did, page 31 or whatever, or what was it last page, 28? Some people wrote down the wrong numbers. They like forget numbers, so make sure you write them all down, odds, evens, that type of thing. Okay, but I'm gonna hand out some old work. Remember, you can always make fixes if you need to.
Stored?
Yes, ma'am.
You don't. And I went bought like 5 more of them. Someone says, we were at
Okay, Mr. Nelson, there you go.
weekend. It says, I think
Davis.
and then I have
Every day I go in there, I feel like you're throwing me under the bus.
back there.
I don't want to
One
be
says,
under the bus.
cycles, and then the other one says, I'm not sure.
Oh, then
He
I'm-
don't have
I
one.
don't know. Maybe it's by
Thunder.
so maybe you shouldn't write them.
What's that? You know that scene?
Jonah, here you go.
May I have your attention, please? Joe from Athletico is here. If there are any freshmen or sophomores that need to see him, please go down to the locker room at this time.
Tyler. And Bell. Where's Bell? Right. Star. M. Look at shoes now.
No, we went to the mall, and then we went to,
What's up?
like an ice cream place.
Probably should have.
And then we went to,
Star.
I missed it too.
Jack's sitting right here.
Yes.
Okay, Bell.
I just take a picture of it and be like,
What?
like, you just like keep it, right? Yeah.
I wrapped it all over the weekend.
Your counter.
yeah.
Jack.
I missed one,
Joint.
just one.
Well, you're throwing me off by wearing black today. Normally you never wear black.
I got this.
I think you wore a red shirt every day last week. Pretty sure.
Oh, and then the last one's a picture of David.
Alright.
It says yes on the left and David on the right.
Davis. Tyler. Good thing I only have 2 Spencers.
That's the last one.
Alright, hey, if you did not get 2 pieces of paper back from me, it's because you didn't turn in the homework assignment. You need to get that turned in. Okay? Did everyone get 2 at least? You did? You still owe me something. Okay? Alright. Check your grades online at some point. Don't throw these away right away. Check your grade to make sure I entered them, because I do make mistakes. I understand that. I grade everything, grade every problem. Sometimes, like, you just didn't read the second part of the question, so I circled it, or maybe I put an X next to it, and maybe I didn't take all the points off. You notice that you had like 20 X's on your paper, but I only counted like 4 off, because maybe you just forgot the same problem, like you forgot to do the same second step on every problem, that type of thing. So I'm kind of lenient that way. Sometimes it's just as easy as like, I noticed your math was correct, like everything you did, but somehow your answer was different than what you had before that, the step before. Like you weren't thinking about it. You suddenly changed X to the 4 to an X to the 12 for some reason. Don't know how that worked, but you did it. So I just circled it. Sometimes I don't count those wrong.
Does the back of this book have answers?
Yes, they have odds.
I really could have checked problems. I could have checked problems.
Yeah, could have.
Can you come here?
Yeah, again.
I'm confused on this one.
Yeah.
Yeah. Where do you?
You gotta move this to the bottom first.
Oh!
So it should be a fraction.
Yeah, I'm gonna put that at the bottom.
You gotta move to the bottom, because that's
Yeah.
like power.
Oh, yeah.
Mr. Ward?
Is it
Yes.
worth redoing or not?
Yes.
No.
What do you got?
It's really not worth
I'm gonna remember now.
a whole paper for one problem. Nah, it's not worth it.
I'd multiply the 3 times 4. And then for the x's, add the part. When you add the part,
What kind of math? We didn't get
you'll probably not see what the odds are.
I know.
Either the answer or your x is gonna be different.
We'll make a signature
That's how you do it. And if you want, you can write that fraction. Fraction or how you want it.
Get around to
Down to the power on the inside.
Maybe actually
That would be first. Combine all this. That might make it easier, because right now it's easier to add. Questions? Fire away, what do you got?
Hey Tyler. And they got, and they're like, I was told that
Multiply, divide, and you just can't add it.
gave the paper.
Yeah, unless they break down to be the same exact
Well, our class.
I would distribute that 3 times. So you just take that power times that. So when you take it times 3, take the top number times 3 to one.
So do we get class of time one for
me.
and then
Oh, and then we sped up. No, because then we screeched the tires because the truck was coming from the name. And he made it.
Easy.
Good.
do we get
And we said the wind probably helped it over the Yes, I am. We put the donut on it yesterday and it looked so good. I was like the rings all black.
Still too high. Winner check to see.
Just 10 miles to pace. And just do that for just something outdoorsy that'd be
Say my name?
Nothing.
Oh, okay.
So this is too much homework.
No.
I'm going on strike.
Ha. Doesn't work here. You guys don't have a union.
You think we'll get out early?
Today? For what?
That's what I said.
No.
Why are we gonna get out early?
I didn't get to wear shorts today, so no.
Why are we?
They gave me shorts all last week, and then this week where it's actually hot, they don't give me shorts. No, we're not getting out
School's
early
not
today.
gonna let us out.
We have a game tonight. There's no way.
Either way, it's good.
Why would we?
That would have been a good day to wear shorts. I'm just saying. Last week it was like 70s. They let me wear shorts all week. I look forward to the little things in life, like allowing me to wear shorts. Because it makes me feel more comfortable.
weather report is
Wait, you can't wear shorts?
No, we're supposed to wear like dress pants and like ties. Today's the game day, so I can wear those.
He's able to wear shorts today.
He's wearing shorts? Yeah, you just subtract power. Divide the numbers like the 20 and the 5, and then just subtract power, top minus bottom.
if you multiply and add it.
His wardrobe probably never even changed. College teaching. Hey. Yeah.
Remember, you can always stop in after school. I'm here till about 5 o'clock tonight if you want. And then tomorrow morning I'm here, I don't know, 7:30, 7:40ish. Oh, but we do have a student council meeting tomorrow, don't we? Yeah, right. Yeah.
The guest password now.
7:40. It'll be quick. It's just to make sure, like, if you don't have numbers for people and stuff, we just get that information. It's easy. It's just a recap. For what? Oh, yeah. And that's just kind of thing, like, this week is very easy. We just confirm, like, hey, did you talk to your person? No? Go talk to them. Like, don't wait.
Or do you know why the guest Wi-Fi has the password on it?
The which one?
Yes.
No, they changed it. They changed it. The teachers are having problems with MacBooks and stuff with it, so they changed the password. Like, they actually put a password on it. They're gonna fix it this week.
Oh, okay.
Trust me, it'll go back to the free thing.
Do you know what the password is?
No, they haven't told me.
Do you have an answer thing? What do you mean?
I only got through number 3 so far. I haven't worked on it
Check
since last
this.
week.
I feel like that should not be my final answer.
I only got through 36.
That's like my final answer. But
Since
simplified it.
Why'd he go 44 and 64 and 2?
She knew that it was
So
Yeah, she knew.
that's not right.
It's not.
No, 54 is 227.
Oh.
So that'd be a 2, and then you can subtract.
I hate to
2, that would be a 2.
because I was literally first of all,
And now you can subtract 3. Negative 1.
Negative 1.
Make sense?
Yep.
Yep. Continue on with the answer key.
So you get 2x and 2s.
I just shut my laptop. You're a hero. Yeah, but I wasn't even playing. That's like my
What do you got?
This one right here, the 3 just go to the 2.
Yeah, distribute to the top because you're gonna multiply it and then you can simplify that fraction. Well, those papers just fell out.
Well, I have a question on 26.
Yeah.
How do I do that?
26. I would just take the square root of top and bottom. They work out nice and pretty. Because you can't see.
Just leave it as 11 over 3?
Done.
I don't write it as the next one.
No, no. If you do, it's fine. I'm not gonna check that though.
And then it's got 6th gen i5 6200, but it only has 128 gigabyte SSD. So I'm gonna put in 1 terabyte hard drive using a SATA drive. It's in there, and then RAM's upgradable. It's on 8 right now. So if I need to, I can upgrade to 16, but I don't think I need to. And if I truly need to, I can upgrade from a 940M to a 960 or 960M. 8. Minimum is 8 for most games now. It used to be 4, but like. 16 is like maximum. There's no point for 32 right now. Like Witcher, if you were to be running Witcher 3 on max settings, you'd only need 16 gigs of RAM. But you'd also need like a NVIDIA GTX 1070 or 2 Titans. This is all just in Spanish too, but. See, but what are you gonna do when you go to class?
Wait, fine, I'll cover it.
I'm just gonna get a PC for college.
Email me.
You know, walking around with it to class. Dude, I gotta sit in the back.
I can see him just plugging it in, bringing in a monitor, and just using his freaking desktop.
Just 36 through 40?
No, okay, so we had a spare monitor in the garage, and I hooked that up, but it doesn't have any sound.
What's up?
Okay, I was gone, so I haven't watched the video yet.
So the only way to hook it up is my headphones. So I've
How do I
got
do
my monitor hooked up to
30?
my computer, and to the side, I've got my TV hooked up to my Xbox.
Divide them first,
So that's pretty dope.
and then take the square. Because those divide out even.
Dividing, you just cross. Dividing, I cross like the X out.
Yep. And 24 divided by 3. And then you should be able to take the. You should be able to.
8x to the third.
Yeah, and then you're taking the square root of that.
So it'd be
Then you can separate again.
2 square root 2x. It's probably like that, so I'm showing
So what do you get?
2 square root 2.
For the 8, but you still have to deal with the x.
2 square root 2x. That's 2. That's outside.
X, there's an x outside, I think, too. 2x, square root 2x.
I don't
x to the third breaks up to be x squared times x. So,
Don't put undergo in your room.
that doesn't sound very confident.
Neon blocks.
Number 98. How do you
Distribute the 1/3 there.
so that become factors?
Yep. And 6/3 and the 125. When you put a 1/3 on it, you're taking the cube root of 127. Okay. Or 127. Yeah.
Same.
Yeah, so you figure out that.
Just Snapchat.
You think so?
They're basically like mine.
Because you didn't sound confident when I left it.
I just need to watch the video when I was home.
Let's see, is that video uploaded?